Hello students, today we are going to discuss about the chapter carbon and its compounds. So we have discussed many elements, we have studied many elements in periodic table. So carbon is an element and it is a non-metal. So the first point is, the chapter is carbon and its compound. So carbon is an element. Carbon is an element. It is a non-metal. Three types of elements are there: metals, non-metals and metalloids. In periodic table we have discussed, we have studied. So carbon is an non-metal. So carbon is an non-metal. Carbon is a non-metal element. Its symbol is 6C. That means that is the number of electrons in carbon atom is equal to 6. Number of protons is equal to 6 and number of neutrons is also 6. Why? Because electrons and protons is equal to the number of atomic number. So it is equal to the atomic number of carbon atom. Now the neutrons can be calculated by the atomic mass minus atomic number. So it is equal to atomic mass minus atomic number, and that is, in the case, here is the atomic number and here is the atomic mass. So if we are going to write it like this, so it is the atomic mass and here it is the atomic number. So it is atomic mass minus atomic number, that is 12 minus 6, it is equal to 6. So number of neutrons is equal to 6. How we can calculate it? This is the method. Now if we are going to discuss about this 6C12, so number of electrons is equal to 6. So I am going to write here the number of electrons in carbon atom is equal to 6. So the electronic configuration of carbon atom in the shells. So an atom has shells, in center, at the center it is nucleus there, and outside the nucleus there is the shells, K, L, M, N and so on. So it is the electronic configuration of carbon atom in shells is equal to, electronic configuration means the distribution of electrons in the shells, that is the distribution of electrons in the shells. So here is the 6 electrons. So the first shell has 2 electrons sorry, it is 2 electrons and remaining 4 are there, so it is going to be in the second shell. So 2, 4. it is in the K shell and it is in the L shell, right? So why it is so? Because in first shell it is 2 electrons, it is called the duplet, and in the second shell it is the remaining electrons, right? And it can be filled up to the maximum of 8 electrons in the second shell. How it is calculated? Because I am going to write here the number of electrons, number of maximum electrons filled in the shell is can be calculated by the formula 2n square, where n is the number of shell. So where n is the number of shell. So here in first shell, so for first shell n will be 1, so it comes 2. So it is in first shell there is 2 electrons, and it is called the duplet. First shell has completed its duplet. Now at the second shell it is 2. If n is equal to 2, then the number of electrons will be 8. So here can be maximum electrons can be 8, but we have only 6 electrons there. So 2 and 4 electrons are there. So 4 electrons remaining in the second shell. So now the point is, there are the 4 electrons in the outermost shell of the carbon atom. So there is 4 electrons in the outermost shell of carbon atom, right? So we know the electrons in the outermost shell can be shared, can be donated, can be accepted in the outermost shell, and that is called the valency of the atom. So here is the 4 electrons in the carbon atom in the outermost shell. So now if we are going to discuss this electronic configuration in the subshells, so I am going to write here the electronic configuration or you may say the electrons distribution in the subshells. So the electronic configuration in the subshells. What is subshells? Subshells are of 4 kinds. So I am going to write here the short subshells. Subshells are of 4 types. It is S, P, D and F type, right? S subshell has 1 orbital, P subshell has 3 orbitals, D subshell has 5, 1, 2, 3, 4, 5, and F has 7 orbitals. So what are these shells, subshells and electronic distribution are there? So here we can see, I am going to make here the small chart for the convenience of your understanding. So here is the shells, atoms. An atom has shell. In shells there is subshells. Subshells are of 4 types. These shells are of K, L, M and so on. And subshells are S, P, D and F. 4 types of subshells are there. And in subshells there are orbitals. These kind of orbitals, right? S has 1 orbital, P has 3 orbitals, D has 5 orbital and F has 7 orbitals, right? In orbitals there are the electrons resides, right? 2 electrons in one orbital, in one orbital that is spinning oppositely. There are two electrons in orbitals. In an orbital spin oppositely. By which the magnetic direction, the electronic direction becomes neglect. So here two electrons in orbital spin oppositely. So here is, if you are going to see this, one electron at this direction and the other one is this direction, like this. So each orbital has two electrons spin oppositely. Clear? So in the carbon we have discussed, the carbon has 4 electrons in outermost shell. So electronic configuration, the electronic configuration in the subshells is, so if we are going to discuss, this is the 2, 4. So first electron in first shell, the one more point is there, that is in first shell, number of shell, first shell there is subshells, only S in first shell there is only S subshell, in second shell there is S and P, in third shell there is S, P and T, in fourth shell that is S, P, D and F present. And ahead the orbitals, the shells, all kind of 4 orbitals are present in each shell, right? But in first it is only S subshell is present, no P, no D, no F. And in the second it is S and P only, and in third it is S, P and D only, right? So here, if we are going to see here the electronic configuration of the subshells, so 2 only S will be there, and S has 1 orbital and 2 electrons resides in that, so it is 1 S2. 1 indicates the number of shell, S indicates the subshell, 2 electrons are there, right? So here next is the first, it is the second shell, first electron goes in the S, 2s2 fulfilled. Now next is P, 2p, so 2 remaining, so 2, so it is 2, 4, 6 electrons has been fulfilled of the carbon atom. So it is the electronic configuration in the subshells. Now if we are going to discuss about the valency of the carbon, so far we have discussed that carbon has 4 electrons in outermost shell, 2 in the first shell and 4 electrons in the outermost shell, that is second shell. Total is 6 electrons. So the valency will be, we are going to discuss about the valency of the carbon. So here the electronic configuration of carbon is equal to 2, 4. So you may see here there are 4 electrons in outermost shell. So it needs 4 electron, carbon atom needs 4 electron to complete its octet, right? Octet means 8 electrons to the outermost shell to achieve the nearest inert gas electronic configuration, because every atom tends to complete its octet. So here there are 4 electrons in the outermost shell. So carbon atom, the point is the carbon atom needs 4 electrons to complete its octet, and octet means that is 8 electrons in its outermost shell. So carbon atom needs 4 electrons. 4 it has, that means it is equal electron, that means 4 electrons it have, 4 it needs. So that means carbon tends to share its outermost electron in most of the cases, not in each and every case. For example, in carbides it is going to be accept the electrons, right? So but in general terms, a carbon is going to share the electrons, to share its 4 outermost electrons, right? So carbon atom in generally not in each case. For example, in carbides, it is not so, right? So carbon atom generally share its 4 electrons with the other atoms. That's why share its electrons, that means it forms the covalent bond, because by the sharing of the electrons the covalent bond is formed, right? So here atom states the covalency of carbon atom is equal to 4. Covalency means the valency comes from the sharing of the electrons. So by the sharing of the 4 electrons, it completes its octet, right? So the covalency of the carbon atom is 4. Now the next point is, for example, CH4. CH4 carbon has 4 electrons and 4 hydrogen atoms are there. So hydrogen has 1 electron, 1 and 1. So it is going to share. When it is going to share, the covalent bond is formed by the mutual sharing of the electrons. So it forms the 4 covalent bonds with the different 4 hydrogen atoms. So here it is CH4. So it forms the CH4 molecule. Now the point comes the tetravalency of the carbon atom or the tetravalent carbon. So tetravalency. Now the point comes tetravalency. What is the tetravalency of the carbon atom? Means what is the tetravalency means? It is the question. It is the question arises here. What is the tetravalency? So tetra means 4. This tetra indicates 4 number, right? And this valency is this represents the valency, right? So here we have discussed that the carbon atom has 4 electrons in its outermost shell that is going to be shared in most of the cases. So that means the valency of the carbon is 4. That is the tetravalent carbon, means carbon has 4 valency. That means carbon is tetravalent. So that is 4 valency. Tetravalency means 4 valency, right? So carbon has 4 electrons in its outermost shell, to which it is going to be shared. We share to complete its octet, that is the covalency of carbon atom is 4, and that is called the tetravalency of the carbon atom, and that is called the tetravalency of carbon atom. Now we are going to discuss about the occurrence of carbon. So occurrence of carbon means carbon, in which forms the carbon is present in the earth, right? In the earth crust or in the atmosphere. So here we are going to discuss about the occurrence of carbon. Occurrence of carbon. So carbon can be found in two forms. First is in combined form. And the second is allotropic form. Allotropes of carbon. Allotropes are the different forms of an element present in the atmosphere or in the earth crust or wherever it is. So it is the allotropes. Now combined form is, in three forms it may be present. The first is the solid state. So in solid state, that means the carbon atom present in the earth crust or in the atmosphere in the combined state with the other elements. So for example, in the solid state, right? For example, CaCO3. So here carbon is present with the oxygen and calcium, right? So carbon is combined here with the other elements. So carbon is in combined state and it is solid. It is in solid state. So that means carbon is present in solid state with the combined form. So here the next is liquid state. Where the carbon is present in liquid form with the combination of the other elements. For example, the petroleum gas we have used in the house, right? In the cylinders, the LPG cylinder is there. So isobutane, propane, so it is CH3, CH, CH3 and CH3. So it is isobutane. It is present in the LPG cylinders in the liquid forms. So carbon is there with the combination of hydrogens. So it is a hydrocarbon. Later on I am going to discuss about the hydrocarbons. So here is carbon with the combination of the other elements in the form of liquid state. So now the next is gaseous state. So in gaseous form, for example CO2. So here CO2 is a gas. It is a gas. So CO2 is a gas. It is the liquid. So CO2 is a gas. Carbon is present with the combination of the oxygen in the gas form in the atmosphere. So here the combined form of carbon is solid state, CaCO3, liquid state, it is isobutane for example, gaseous state it is CO2. Now come to the allotropic forms. So allotropes of carbon are two types. The first is the crystalline form. And second is the amorphous. Now what is this crystalline and amorphous stand for? This crystalline stands for the true solids. These are the true solids. And amorphous are actually looking like the solids, but they are not the true solids. They are just like supercooled liquids. It is also called as supercooled liquids or pseudo solids. Supercooled liquids. or it may be referred as or pseudo solids. So that means it is not a true solid. It is not a true solid. Amorphous is not true solids. So now the crystalline form, it is a true solids. Why? What is the difference between them? Actually, crystalline form, the true solids have the definite geometry of the molecule, of the structure, right? And the amorphous doesn't have the definite geometry of the molecule. So here, the crystalline form of the carbon atom, we are going to discuss about the carbon allotropes, the crystalline form. It is two examples are there, that is diamond and the second is graphite. And the amorphous form of carbon is lamp black and then the coke and then the carbon gas. Here it is the four kind of amorphous forms of carbon atoms. So now we are going to discuss one by one about this, about the diamond, graphite, lamp black, charcoal, coke and carbon gas. So first is the diamond. Actually, what is the structure of the diamond is, in diamond, each carbon atom, the 4 valency of each carbon atom is satisfied means joined, means sharing. So satisfied by the neighboring 4 tetrahedrally arranged carbon atoms, right? So in diamond, each carbon atom four valency is satisfied by its neighboring 4 different tetrahedrally arranged carbon atoms, right? And this makes the hardest structure of the earth. On the earth, it is the hardest structure, and this forms the hardest structure, or you may say the compound, better to say compound, hardest compound. On earth, that is diamond. Clear? Now we are going to discuss about the graphite. So here graphite is, the second is graphite. So what is happening in the graphite structure? The carbon is present in the layers, right? The different layers are there. So in layers, in graphite, the carbon layers are there, and each carbon atom of a layer, 3 valency out of 4 valency of the carbon atom is satisfied by the neighboring 3 atoms of the same layer, and the 4 valency becomes free between the 2 carbon layers, right? So here in graphite, carbon is present in layers, right? and each carbon atom in layers, in a layer, each carbon atoms 3 valency out of 4 is satisfied by its neighboring 3 different carbon atoms, and fourth valency become free between the two layers. Between the two layers, the fourth electrons becomes free. Fourth valency means fourth electrons. That is the fourth electron. Of carbon in graphite. So these free electrons between the layers is responsible for the conductivity character of the graphite, and because of these free electrons, the one layer of the carbon in the graphite can slide over the another layer of the carbon. So that's why the graphite is used as a lubricant. So here I am going to write, because of these free electrons between the two layers are responsible for conductivity character of graphite, and because of this, and because of these free electron, one layer can slide over another of carbon may slide over one another, and that's why the graphite is used as a lubricant in the automobile industry mainly. So here all about the graphite and diamond. Now come to the amorphous form. Now we are going to discuss about the lamp black, charcoal, coke and carbon.